Welcome everyone. I am Laura, the Marketing Director at Carbon Clean. And I'm delighted to have you join us and be guiding you through our session today as we introduce you to the world's smallest industrial carbon capture technology. It's not about the next 2 hours, but the next decade of delivery. Carbon capture solutions are an essential step towards mitigating climate change, and we need to take urgent steps to ensure CCUS is available to contribute to net zero goals. Before I go on to discussing our amazing speakers and agenda, I want to cover off on some light housekeeping. First, this event is being recorded, and you will receive a copy of the recording in your inbox tomorrow. Second, we encourage all your questions. In the Zoom control panel, you'll see a Q&A box. This is where you can leave any questions during the webinar. A Q&A will take place towards the end of our event, so please ask questions throughout. And if we don't get to your questions, we'll engage with you post-event. Finally, we want to hear from you during our event, so please make sure to use the chat box feature for comments and keep an eye out for polls. Do also get social with us by joining us on LinkedIn and Twitter using the hashtag #SizeMattersCarbonCapture. Now let's get on to the good stuff, as we have an amazing lineup of speakers and panel debates ready for you. Setting the scene, I would like to welcome our co-founder and CEO, Anirudh Sharma, who's been instrumental in building and developing Carbon Clean into a global leader in cost-effective carbon dioxide separation technology for industrial applications.
Many thanks, Laura, and a warm welcome to this incredibly important day for Carbon Clean and for the future of carbon capture industry. It's gratifying that so many of you are joining us today. We have had over 1,000 people register for this event, demonstrating just how strong the interest is in carbon capture. Carbon Clean has been developing carbon capture solutions for over 12 years. But today, we are introducing something that we believe will revolutionize the sector and finally deliver on the potential for CCUS, that is carbon capture, utilization, and storage, to tackle the emissions and help achieve net zero carbon emissions ambition. We know CCUS is essential if we are to achieve net zero ambition. It can deliver over 15% of global cumulative carbon dioxide emissions reduction needed to achieve that net zero ambition. It is virtually the only technology solution for deep decarbonization and carbon emissions reduction from the cement production, and is the most cost-effective approach in many regions today to curb the emissions, for example, factories like iron, steel, and chemicals manufacturing. In the UK, the Committee on Climate Change says CCS is a necessity, not an option, for reaching net zero greenhouse gas emissions ambition. But without accelerated deployment, heavy industrial sectors risk falling behind and failing to decarbonize in line with national and sector targets. In fact, CCUS deployment must be at least 50% higher than currently predicted trajectories if the world is to reach net zero climate change target by 2050. The good news is that every major emitter I speak to across the cement, refining, steel, energy from waste, and chemical sectors is in the process of defining their carbon capture strategy just right now. Just in 2021, we have seen huge commitments, way bigger than ever before. But there are significant barriers that have been preventing industrial groups moving from interest to actual implementation on the ground. Two large ones are, first, cost is always an issue, and of course, it's a big problem. Building decarbonization equipment and carbon capture plant within existing operating units is expensive and sometimes operationally challenging. What we have seen from numerous studies is the cost of carbon capture is simply way too high today. Secondly, lack of space is also an issue. Conventional carbon capture technologies have required considerable land and space, ruling out CCUS as an option for many facilities out there, as there simply isn't the space available. Just 9 days ago, we published a report with Decarb Connect that shows that space is a huge issue for many industrial facilities out there, irrespective of the geography or the region. So we listened. We are innovators. That's the core of our business. We are passionate about finding solutions to our customers' problems and deploying them very quickly. Today, I'm very proud to introduce our revolutionary solution, CycloneCC, that will change the carbon capture industry forever. CycloneCC will bring the cost of carbon capture down to an average of $30 per ton. It'll reduce the size and footprint of carbon capture equipment by up to 10 times. It'll reduce the capital and the operating cost by up to 50%. And most importantly, it'll cut the installation time of carbon capture equipment to less than 8 weeks. It'll also allow companies to progressively roll out carbon capture capacity with standardized, modular, prefabricated units available that can stack together to increase the capacity in line with their decarbonization trajectories and investment availability. CycloneCC will also provide additionality to industrial groups to trial different options available at their hand. For example, CCUS, hydrogen, biomass. With CycloneCC, they can mix and match and decide which one of their strategies would work best for their sites and for their portfolio of operating plants. We've seen the carbon prices under EU emissions trading scheme rise to 65 euros per ton just this month. But the solutions available today are not cost competitive today, even at 65 euros per ton. This isn't just about bringing a smaller and or a cheaper solution to the market. CycloneCC will be the catalyst for radical shifts in the way we do CCUS, especially for the heavy industry facing cost and space pressures. 44 countries and the EU have set net zero targets now, and CycloneCC will allow emitters and carbon dioxide producing plants in majority of those regions to get started right now. It'll underpin our carbon capture as a service model where we will deliver a design, build, finance, and operate models for CCUS projects for the duration of the contract, overseeing installation as well as aftermarket services. A model that recent Decarb Connect survey has also demonstrated considerable support for, with 41% of those surveyed seeking a fully funded CCUS model, and the rest preferring a mix of self-funded and fully funded carbon capture utilization as a service model. CycloneCC will deliver carbon capture for the many, not the few, and at a cost that makes business sense. But while today's event is focused on the future, our journey to reach this point would not have been possible without the support we have received from our partners. So I'd like to say a big thank you from the Carbon Clean team to Department of Business, Energy and Industrial Strategy, the UK government, the Newcastle University, the University of Sheffield, and Doosan Babcock, who have worked with us to develop and demonstrate CycloneCC technology in the UK. The Department of Energy, the United States government, GTI, and the National Carbon Capture Center, who have worked with us on testing and scaling up the technology in the US. And Cemex and Veolia, who are among our champion customers and best partners working with us to further demonstrate and scale up CycloneCC in actual industrial settings. Lastly, not forgetting our investors that have made this innovative journey a possibility. I'm incredibly proud and excited to be revealing the world's smallest industrial carbon capture technology. But before we take a closer look, I'm delighted to introduce an address from our keynote speaker, Dr. Ernie Moniz, who was the United States Secretary of State for the Department of Energy from 2013 to 2017, and who, I'm happy to say, is supporting Carbon Clean as a recently appointed board advisor. Please enjoy the rest of the event, and I look forward to hearing from you throughout the event. We are on the path to achieve net zero together, and I welcome conversations on how we can collaborate to accelerate CycloneCC and the CCUS technology to achieve our wider ambitions.
Well, thank you, Aniruddha, for that introduction. I'm pleased to join you for this exciting technology launch because advancing carbon capture, utilization, and storage, CCUS, is so central to achieving the deep decarbonization of the economy that is essential to avoiding extreme consequences of global warming and climate change. I will leave it to you to introduce and describe the technology and its benefits, but I do want to provide context for why cost-reducing innovation in carbon capture technology is so critical. The International Energy Agency said it very clearly, and I quote, "We need to take urgent steps to ensure CCUS is available to contribute to net zero goals. A major ramp up of CCUS deployment is required in the next decade." In other words, it's now. We really have to start moving out smartly on CCUS and see an enormous scale up towards the end of this decade and certainly in the decades beyond that. Now, an impediment to deployment has been the cost of carbon capture in particular. So innovation that lowers that cost can unleash a quantum leap in bringing CCUS to scale. We also note how CCUS will help shape the pathway to net zero emissions in multiple ways. CCUS for power plants, natural gas and coal. CCUS for hard to decarbonize industrial facilities like cement plants. CCUS for blue hydrogen, that is natural gas converted with steam to hydrogen with the CO2 captured and then stored. CCUS for negative carbon technologies like direct air capture and bioenergy with CCS. And I want to stress that negative carbon technologies are going to be an absolutely essential part of reaching net zero. In fact, the net practically tells you you're going to need negative carbon technologies in addition to mitigation technologies on emissions. So CCUS has a multiplicity of uses that are absolutely central to the agenda of both mitigating and in some sense offsetting residual emissions from hard to decarbonize sectors. With this broad set of applications, CCUS is a critical enabler. It will enable more renewables, for example, on the grid with reliability. It will enable us to decarbonize the industrial sector that will not be easy to do in any other way. It's also huge for jobs. And it's not only the massive scale that we will need for building out the CCUS industry. Frankly, it will be a scale comparable to that of today's global hydrocarbon industry. And of course, that means a lot of jobs. But it has a second important point, and that is that CCUS will engage the skill sets of many of today's workers and communities who are dependent on today's energy systems. And so there's a very important component of the social justice agenda as well in terms of preserving jobs, good jobs, high-paying jobs for today's workforce. Now, we know there's more work to do. There's work to do on the regulatory front. There's work to do in terms of evolving the business models to incorporate carbon capture and storage at large scale. But now is the time for action, and there can be no question that it starts with carbon capture and technology and innovation and modular solutions, all of which can contribute to rapid deployment and significant cost reduction. And that's what you're all here to hear about. So without further delay, let me turn it back to Aniruddha for really the centerpiece of today's event. And thank you very much.
I want to take a moment and thank Dr. Ernie Moniz for coming here and talking to us about the importance of carbon capture and the role of technology. Next, I am here joined by an amazing panel that's here to talk a bit about what their companies are doing or what the departments are doing as far as decarbonization is concerned, and also tell us a bit about some of the insights, especially from the people who are at the sharp end of the problem of deploying CCUS. Today, I'm joined by the panelists, and I'm just going to introduce them right now. Margaret, do you want to start first?
Yeah, thanks for inviting me, Anirudh. My name's Margaret Mistry. I work in Equinor. It's an international energy company with headquarters in Norway. And I work as a manager in our Future Business unit. Future Business was set up to look for new growth legs for Equinor outside of our legacy core business. And I'm focusing especially on carbon offsetting, carbon removals, reductions and offsets, and looking for opportunities there.
Very interesting area. Anna?
Hi everyone, very happy to be here with you today. I'm Anna Laurent from Veolia. So Veolia is a company that does waste, water and energy, environmental solutions across the globe. And I'm the strategy manager for UK and Ireland. So my work spans across all our operations in the UK and in Ireland, working on what the future of the business will be. And there is a big aspect of it, which is decarbonizing our activities. So I'm very happy to be here today.
Thank you. Alex?
Yes, and thank you very much for having me. Alex Millward, I'm from the Department of BEIS, Business Energy Industrial Strategies, and I'm the Director for Carbon Capture, Utilisation and Storage. We're together working with a number of colleagues where they're laying the foundations for the government's 10-point plan for carbon capture, utilisation and storage to enable the capture of industrial emissions and prevent them from going into the atmosphere, as well as blue hydrogen, as well as adding to our energy security through gas-fired power stations with carbon capture. So we like the energy that hydrocarbons bring, and we just want to get rid of some of the waste product and put them safely and permanently away, and delighted to be here.
Perfect, thank you. I think that actually brings me very, very nicely to a question for Equinor. So Margaret, Equinor has an ambition to achieve net zero. Could you talk a bit about the strategies you are deploying to achieve net zero and some of the examples of how this is happening?
Sure. So there's three main levers we have for reaching net zero. The first is efficient oil and gas operations, so reducing the carbon footprint of our oil and gas production. And there we've got an ambition to be carbon neutral by 2030. Electrification is a really important tool to get there, and we've just announced recently initiatives on our Sleipner and Troll fields. So that's a project example there. The second lever is renewables and low carbon solutions. So our oil and gas production is going to be declining after 2030, and then we'll see investment really shifting towards renewables. So we expect to spend about 50% of our capex on renewables and low carbon solutions after 2030. And in addition to a growing offshore wind business, it's growing ever bigger, we focus really on very large low carbon solutions projects in major industrial clusters. So for example, in the northeast of England, we've got three projects currently where we're doing gas to power with CCS. And that brings me to the third lever, which is CCS and especially storage. So we've got ambitions to grow from 5 to 10 million tonnes of CO2 stored annually in 2030 to 15 to 30 million tonnes stored annually in 2035. And our flagship project there is Northern Lights, which I'm sure you've all heard of. It's a partnership with Total and Shell. And that is the world's first third-party CO2 storage, and we're storing safely 3,000 metres below the seabed CO2 for our customers. And we're really hoping that that will bring us to our first 5 million tonnes of storage when we get to phase 2.
Oh, wow. And I do want to ask, I mean, Veolia is a company that's known for circular economy and I know you value that quite a lot. I would want to understand the strategies or the goal around decarbonization of EFW plants, and if there are any examples you want to maybe talk about that.
Sure. So yes, when you look at Veolia, we've been pioneering circular economy for decades already, trying to close the loop as much as we can, recycling 2 million tons of material every year just here in the UK. So it's really at the heart of what we do. But obviously, when you look at our portfolio of activities, energy from waste is a big part of our current carbon footprint. And it's been really valuable to divest lots of waste from landfill, avoiding emissions from landfill. But we need to obviously deal with the emissions from the sector. Our primary way to decarbonize it is to increase recycling. So this is really what we've been focusing on, increasing recycling infrastructure, working with DEFRA and the rest of the government on the resource and waste strategy. But when you look at the residual emissions and the actual footprint of a site, there is definitely a need to capture carbon. So this is why we've partnered with you on the trial for this technology at our facility in Sheffield, which is great to learn and together explore this more. But we're also looking at recovering extra materials after the combustion process. So it's really no silver bullet. It's really looking at all the options for us.
Exactly, and I think that's a great point, that there is no silver bullet. We need to be coming up with all options and deploying all the options. I do want to sort of move to Alex now and try and maybe focus a bit about the industrial decarbonization and the place of heavy industrial decarbonization within the government strategy, wider government outlook. If you could maybe talk about that.
Yeah, I think when government committed to net zero, it recognised a number of strategies. First of all, don't emit if you don't have to. Secondly, if you do have to, do it as efficiently as possible. And thirdly, if there are some of the so-called hard-to-abate sectors, then the balance between that life-enhancing quality of being in work, providing services which are essential for our economy that we all live and breathe and benefit from daily, then let's use technology to be able to remove the parts that we don't want through carbon removal and permanent and safe storage away. And that's largely in that sort of heavy industry, as you say. There are a lot of newsworthy items at the moment around that industry for lots of different reasons, but there's lots of things which we all benefit from: steel, cement, energy, waste removal, concrete, and other sort of industries where a large number of people are employed today, and we can use technology and innovation. The science and innovation that does exist in the UK can continue to thrive and help us achieve net zero in the short time that we have to do it.
Yeah, and I can certainly ascertain the fact that we've been beneficiaries of the government's long-term strategy. The current technology that we're deploying is actually funded by the government's grant, and that has allowed us to achieve a massive reduction in this size, and hence the cost of carbon capture as well. So, coming back to the residual emissions, I think it's quite important to realize that there will be value of offsets as well. Margaret, what are the big changes you're seeing as far as carbon capture as an industry is concerned?
Yeah, so in the market, it's really, I think the urgency that Alex just mentioned is really being reflected in the market, and we're seeing prices increasing. So the EU ETS has been trading over €50 per tonne lately. But in addition to that, individual countries have been increasing carbon taxes. And you mentioned offsets. The voluntary carbon market is also really growing. I think last month or even this month, Bloomberg reported that 274 million tonnes of credits had been traded. And that's more than the annual emissions of Spain. So that market is really starting to heat up, and that's driving investment into BECCS, negative emissions, all of these solutions which we need. So we see, with all these trends coming together, and I want to mention as well the increased collaboration in the space. There's a lot of partnerships, capacity expansion happening. All of these trends together, I think, are going to mean that carbon capture and storage is going to get competitive and cost will come down. We think around 2030 it will become viable as an alternative.
It's a very, very interesting point, especially around the offsets. I mean, I want to come to Anna from here because, you know, energy from waste industry has a massive potential to offer negative carbon emissions as well. I think you touched upon that, but it'll be interesting to learn a bit more about the challenges you face in terms of decarbonizing specific sites.
Yeah, I think when you look at the overall sector in the UK, there are about 50 facilities. Veolia portfolio, we have 10 of those facilities, which are actually all so-called dispersed sites, which means that they are kind of far away from the clusters where CCUS is looking to be developed first, and they are kind of very limited access to other options to transport the CO2, either via shipping or road and rail, because we're close to where the waste is emitted. So whether it's central London, in the middle of Birmingham, Sheffield, etc., it was built to minimize logistics around waste transportation. So this is a challenge in itself when you look at the portfolio. I think looking at how the overall sector can be decarbonized is a really important thing to look at, but we should not use a kind of blanket approach on how this is going to be done, because you will have different speeds and varied ways to do that. When looking at the biogenic aspect of the carbon emissions, currently, because we have about 60% of the waste that is going into residual waste and then treated in energy from waste, this is coming from organic waste, and then 40%, which is about fossil, so all your plastics and so on. So there is a big opportunity to, one, reduce that fossil aspect through increased recycling, which is really what we're working towards. And then obviously if you put capture on top of that, then you have this ability to generate negative emissions from that biogenic content of the waste, which is very interesting in terms of offsetting and helping the overall country to achieve net zero.
Exactly. I mean, I cannot emphasize enough how difficult it would be to reduce or remove the emissions, especially residual emissions from the heavy industry. Alex, from your, you're at the heart of the action. So from your day-to-day interactions with the industry, are you picking up the same messages as well? That there's not enough space, maybe it's too expensive?
I think it's very consistent. Actually, Margaret talked about the partnerships. I think the public and private partnership has been very strong and has advanced us further before. There has been a couple of times in the UK where we've had a false dawn on carbon capture because the costs were high and there wasn't enough support for the benefits that time. I think the global, national, local conversation is very different. But I think it's fair to say not everybody is convinced of this technology. Or the cost of this technology. So we need to tread very carefully in that partnership, and I think that's happening really, really well. And I think part of that and the cost that you mentioned is why the starting premise is in these sort of closely concentrated clusters, whereby we need to look after, for sure, the shareholder of the private sector and the stakeholders and employees there, as well as the taxpayer, all of us,
yeah.
and for the price of this. So we need to sort of start with something which is the lowest cost possible to start with until Margaret sort of points out that cost reduction kicks in. And so that's why they'll be in those close concentrations where a pipeline can be used to connect a facility to a store. And then what we're calling non-pipeline transport, which may be shipping, maybe rail, maybe road, to be decided and designed. The Northern Lights is using shipping, which I think will advance the world's knowledge, which would be fantastic. And then we need to sort of get into some more inland solutions as well. How that will work, don't know. And then we're working very closely on that economics to get that balance between the private sector stakeholders and the public sector stakeholders, whereby currently under the capital system, industry is not as incentivized, particularly in a global landscape, to initiate this without support. So that's why the government wants to get involved to offer the initial support And then, certainly all of the private sector have said they want the government to sort of step back and get into a regulated involved. No one wants sort of continual subsidy. It's to get it launched and then sort of step into regulation rather than ongoing subsidy support.
Yep. No, I fully agree with you. I mean, the investment from the government would be actually to just get the technology deployment going, and once we are above that, the first hurdle, then after that it should probably be hopefully free flowing from there. And I think UK is a great place. I mean, look at what has happened with wind energy. Just the deployment has gone really in multitude of directions. One of the things that we are quite passionate about, and that's what this whole research started, of compressing the size by 10 times, is to solve the supply chain problem. If you're thinking about deploying the technology 500 times at a scale where it is today, how do you actually source, how do you manufacture, how do you produce, and how do you deliver in a fully skid-mounted modular fashion? So, Margaret, I mean, when it comes to dispersed site, you've already talked about the transportation, but do you see a role for modular skid-mounted equipment for dispersed sites to reduce the cost in future?
Yeah, I think that's going to be crucial. I mean, I've talked about this enormous storage potential that we see on the Norwegian continental shelf and in the North Sea area, up to 30 million tonnes of storage we've got to fill. But to fill that, we're not only going to be looking for large sources of CO2, we're going to need to aggregate together lots of smaller sources. Now, to make that viable for the smaller emitter or customer, they're going to need small-scale equipment, and they're also going to need lower costs. So getting down the cost and the size is going to be really important to, really stimulate this industry moving forward and fill up the storage. Yeah.
I think, Anna, again, the same question. Do you think the industry might benefit from standard scalable modular solutions that you can deploy whenever you want?
Yeah, I think when we started to look at the portfolio of our sites within Veolia, the first question, and it's a showstopper, is do we actually have space on site to capture the carbon? Even before looking at where it's going to go, long-term storage, or utilizing in some way or form, is actually, do we have enough space on site? Because most of our sites are, really optimized in terms of the layout, and it's really tight. So when you look at the traditional solutions to capture the carbon, it's almost as big as the energy from waste plant itself, which obviously is not working for us. So having that reduced footprint is absolutely critical and makes it viable for much more sites. And then you can go the step after, which is, how, once we've captured the carbon, what do we do? And it's also important to look at, maybe ideally you want to capture everything, but actually there might be space to just capture a proportion of it, depending on what space you have on sites, and the other, solutions that you put in place on that site. So it's really, that modularity that is going to be really, really helpful to deploy it at scale.
Yeah. And I think if we start to sort of deploy this in the UK, I think that it would certainly be a role for the UK as a country to start exporting this knowledge outside of the UK. So, Alex, do you see there could potentially be a role, and if yes, then what would that role be?
Yeah, for sure. Actually, first, sort of come back on a couple of points here. Agree entirely, actually, with Margaret and Anna in that. And in addition, I'm relatively new into public sector, so I'm learning an awful lot of other things. And the other advantage of miniaturisation then comes to local acceptance. Whereby, and with our sort of devolved decision making that happens in this country, local buy-in to the choice is very helpful. So, a doubling the size of a plant due to capture tends to increase resistance. So, miniaturisation and the things that humankind has achieved since we've been around with the innovation and miniaturisation and cost driving down is really important. So that sort of planning permission would be really important. And of course, we sort of talk about safety as well. Safety would also be another element. I think the way sort of UK government works, you talked about standards, and I think what my experience is, everyone loves a standard as long as it's my own standard. So there will be continued innovation from competition. And I think that will sort of make us all better and safer and help drive the costs down as well. And as part of the 10-point plan that I mentioned, we do estimate there'll be up to 50,000 new jobs created from the UK good quality jobs, partly as some industries transition and to enable a fair transition from one industry, oil and gas, which Margaret talked about might be reducing, into a growing one that can do that. And I would be incredibly proud if we could all then enable that capability, that knowledge, to then help the whole world decarbonise. Because it's no good just UK being at net zero. We need the whole world at net zero. Mother Nature's not giving us any time extensions. So that would be amazing if we could get that all working.
Yeah, no, I mean, exactly. Mother Nature is definitely not giving us time. We are less than 3 days away from COP, so I would take this opportunity and ask a question. If you had one wish and a magic wand, what would that be?
You mentioned COP, so now I want to talk about Article 6, which is a really boring wish, but I want them to sort that out at COP. Just forward momentum and not wasting time on disagreements and arguments. That's what I'm really hoping for from this COP.
Yeah, I think for me it's really building on the Paris Agreement, actually having the right policies in place to deliver it and not fall short, but go beyond and have that trajectory to keep with the 1.5 trajectory and have it, the world net zero by 2050 would be amazing.
Alex?
Yeah, no, I'd agree with that. I think the one addition I'd add is I'm a believer in the net zero, and that net does require a bit of pragmatism, and that may have to allow certain countries a pragmatic route through it, which isn't necessarily sort of consistent with some of the messages I'm hearing through. So I think some pragmatism and compromise to sort of focus on the goal of keeping us within touching distance of the 1.5 degrees is the most important, and get that commitment to make it happen.
Absolutely. Well, we'll all be watching what happens at COP negotiations. I want to thank our panelists for joining us today. Thank you so much. And I want to now hand it over to our Chief Technology Officer, Prateek, to introduce the technology in a lot more detail.
It's a pleasure to be here to introduce the world's smallest industrial carbon capture technology. Thank you, Anirudh, for the introduction, and delighted to follow on from Bays, Equinor, and Veolia, who shared great insight with us today. Listening to those at the sharp end of industrial emission has been crucial as we have developed CycloneCC. We started commercializing in 2014 and have since raised 42 million in investment and worked with some of the biggest corporates. Our technology has been proven at scale in over 10 countries across 46 installations, capturing well over 1 million tons of CO2. There are many key partners that cannot be with us today, and two I want to highlight are in the US, where Carbon Clean has built a mobile skid integrated pilot plant in partnership with GTI with support from US Department of Energy. So back to today and the unveiling of the world's smallest industrial carbon capture, CycloneCC. Our fully modular carbon capture technology that is set to disrupt the market and make carbon capture simple, affordable, and scalable. High cost has been a significant barrier to adoption, a problem now being solved by Carbon Clean. We will explore the technology further in the panel session to come, but it has been successfully pilot tested, and we are now commercializing at 10 ton per day and 100 ton per day with select partner for final product rollout by summer 2022 and market rollout by 2023.
CycloneCC is a breakthrough combination of two process intensification technologies: Carbon Clean's advanced proprietary APBS solvent and a novel process technology called rotating packed beds, or RPBs for short. RPBs are a process intensification technology that improve the absorption of CO2 into the solvent. At its heart, an RPB contains a disc of packing material which rotates about its axis. This generates a centrifugal force within the packing, which enhances the CO2 absorption process. The solvent is introduced into the RPB at its centre, where it's sprayed onto the packing via a liquid distributor. When the solvent contacts the packing, the centrifugal force applied to the solvent from the rotational motion forces the solvent to travel radially towards the outer edge of the packing, where it drains down to a sump before being pumped to the next stage of the process. The flue gas is introduced to the RPB from the outer edge of the packing and exits at the inner edge, where the solvent enters. Therefore, the gas and the liquid contact each other in a countercurrent fashion. The flue gas is absorbed by the solvent, and the CO2 present selectively reacts with the active components in the solvent, thereby temporarily locking the CO2 within the solvent.
Doosan Babcock have been delighted to host and support Carbon Clean in the development of their next generation CycloneCC technology at our carbon capture test facility in the UK. Carbon Clean's CycloneCC modular technology allows a significant reduction in equipment size. This allows the deployment of technology in sites where space is constrained or limited. It also potentially enables as much as a 50% reduction in CapEx and OpEx compared to other plant designs. We look forward to continuing our support to Carbon Clean as they continue to develop and commercialise what is an extremely exciting technology.
As governments take greater action to incentivise the transition to a sustainable economy, they have recognised the vital role carbon capture, utilisation and storage, CCUS, has to play. The International Energy Agency state that CCUS can reduce global emissions by nearly 20% and the cost of mitigating climate change by 70%. We are working with more companies than ever. CycloneCC enables scalable, cost-effective carbon capture and has a crucial role to play in helping hard-to-abate sectors decarbonise and more broadly, keep average temperature rises to below 1.5 degrees Celsius.
Thank you, Pratik. And I'm James Hull. I'm R&D Manager with Carbon Clean. I'm joined here today by an expert panel to discuss CycloneCC, a breakthrough technology, and the innovative journey so far.
James, I'm Paul Arwis. I work for a company called CLT. We specialise in helping innovative clean technologies get to market.
I'm John Lee from Newcastle University. I'm a senior lecturer in chemical engineering and I'm responsible for a lot of the background research to do with CycloneCC.
And I'm Stuart Duncanson. I work for Doosan Babcock, Head of Technology Integration, and I'm focused on industrial carbon capture and storage.
Great, thank you. So Paul, can you tell me a bit about the incubation support that you've been able to provide to the Carbon Clean team to enable them to accelerate in becoming a commercial success?
Okay, well, I mean, I'd like to start off by saying that sort of Carbon Clean is pretty much one of the best examples that we're proudest of in terms of our incubation support. We've worked with Carbon Clean since 2014, and incubation support comes alongside government grants, government technology grants to help a company take clever technology and take it to the marketplace. The sort of things we do stretch on the one hand from doing market assessments for companies in particular areas that you want to develop, to looking at incubation, intellectual property, helping people write business plans, everything that could help a company get a great technological idea and take it to the marketplace.
And in your opinion, what would you say are the key drivers for a technology startup to succeed in developing and commercializing new technologies?
Well, the crux really is, do you have a really compelling idea? So not only a clever bit of technology, but something that really addresses a market need, a pain point that customers out there are actually going to pay for. And once you've got that, I think there are two other things that are critical. One is actually having the right founding team. So Carbon Clean were brilliant in that they had a a technical genius and a commercial wizard come together who could really drive the company forward. And that's really pretty much the ideal team to start off a company. And the last thing is, engagement with your customers or potential customers in the future. Getting early traction, talking to them, understanding what they really need. Those really are the three factors that kind of are the fundamentals of being able to get a great piece of technology into the marketplace.
And with respect to CycloneCC, why is this technology coming at the right time?
Well, I'm sure you probably agree that we're about to move into a world of great shortages. We've already seen a huge CO2 shortage in the UK. Energy prices are going all over the place. For many companies, being able to have their own CO2 rather than relying on the market, I think makes a lot of sense, because often CO2 for, let's say, food producers is a very small amount of their costs, but is absolutely vital to actually their production. And we're going to live in a world where energy prices are going to ratchet up and down, and so having the flexibility to be able to use, say, natural gas on your own premises, I think, whilst having very little impact on the environment, seems to me to be a hugely beneficial option that any company should really look at carefully.
For sure. And so Stuart, switching gears, you've worked with us and you've seen CycloneCC in action. What can you tell me about the impact that the technology is likely to have on the hard-to-abate industries?
Yeah, I think the technology is very interesting in the fact that it offers a significant cost reduction and it's modular. When you talk about sort of hard-to-abate industries such as chemical or cement, one of the key problems with integrating such technology is space, and also the fact that often the CO2 comes not just from the energy provision on the site, but also from multiple point sources across the site, because it's a key part of the process. So the ability to offer modular carbon capture technology that can be installed in multiple locations across the site is massively beneficial. And I think the fact that the size of it allows you much more scope and opportunity to do that means that technology is a very interesting option for these types of technologies. The cost reduction, I think, also, as you sort of talk about, in terms of driving CO2 capture for usage is massively beneficial. If you can capture that CO2 at a reasonable price and you're able to use or sell it, then that's a fantastic opportunity. And I think the cost reductions associated with the technology is brilliant.
And how hard do you think it's going to be to integrate this state-of-the-art technology? And how do you think it will change in the future?
Integrating state-of-the-art technology is always a challenge, but one of the advantages of being able to run with a modular approach is the ability to install, one module initially, demonstrate that the technology works, iron out any problems you may have with that, particularly when you're using it on an application that may not be have not been used previously, and you're trying to work through some of those issues, and then seek to scale that with multiple modules. And that's massively beneficial in terms of de-risking the approach.
Yeah, and I suppose along those lines, how do you think the technology adoption will become easier with this modular systems and also moving toward more standardized technology? Is this the right way to go? Is this the right direction of travel?
Yeah, I think standardizing technology offers you, significant advantages. You're able to basically consistently manufacture a similar product, which means when it's out in market, if you have particular issues, you're dealing with one key part of that, and you can make those changes. When you're dealing with a carbon capture plant that's been specifically designed for a particular application at a particular size, you can have multiple sites with different valve sizes, etc., different technologies involved. And that's quite difficult to understand where some of the faults and issues are coming. When you standardise the technology, you're basically able to fault find in one unit and then basically roll that out right across your fleet. You get a better understanding of how your technology performs, where your root cause of failure are, and you're able to basically improve and work on that. And that's highly advantageous. One of the other major advantages will be, I think, moving into the UK space. You're going to have a real issue in terms of site resources, particularly in places like the UK and Europe. So constructing the site is difficult. You're going to have a shortage of staff. and the ability to actually manufacture modules within, you know, an enclosed environment where you can control that manufacture and the quality will give you significant advantages. And as with anything that you standardise, the more you make it, the quicker you get, the more efficient you get, which can only help to drive down the cost.
Exactly. And one of the key features of CycloneCC is a reduced equipment sizing. How important do you think that size reduction is going to be important in relation to decarbonising heavy industries?
I think it's going to be massively important. If you look at industrial sites, they don't have space to burn. It's, you know, space and land's at a premium. So the ability to install technology which uses a smaller footprint gives you significantly more options. If you look at the large industrial providers within the UK or across Europe, often they don't have that space. And if you can offer technology, it's much smaller, it can be modular, it can be stacked. That offers you significant advantages over a specific design of a carbon capture plant. And I think that can only help accelerate the opportunities. The cost associated with that will also mean that it becomes much more applicable to different industries and different companies.
Yeah, and that size reduction, I mean, we focus on that a lot. And John, turning attention to you, you've worked with rotating packed beds for most of your career, and it's a rotating packed bed that's at the centre of the CycloneCC technology. So what is it about these rotating packed beds that make them advantageous for CO2 capture and size reduction?
There are two main advantages. When you rotate the packing, it means that the liquid and the gas involved in this process can move past each other much more rapidly. And so, because they're moving past each other more rapidly, you get good mass transfer between the two phases, the liquid and the gas. And that feeds into the second advantage, which their niche application for rotating packed beds is reactions in the liquid phase that need material from the gas phase. And if you've got a very high rate of mass transfer, then the CO2 can get from the gas phase to the liquid phase easily. So they're ideally suited to carbon capture, and they can handle very high gas and liquid volumes.
And drawing on the point that you've spent a long time researching with rotating packed beds, you've even worked with Colin Ramshaw, who's widely credited as the inventor of rotating packed beds as well. In all of your time working with the technology, what would you say is the most significant development that you've seen during your experience, particularly in the space of CO2 capture?
For a long time, it was a box and it had inputs and outputs, and we only measured really on the inlet and the outlet of the system. And then in the last 10 years, we've been able to look inside using tomography, and that has given us a much better idea about how the liquid behaves inside. And from those measurements, we've been able to develop better packings, and the recent projects we've done have utilised those better packings that have been developed using tomography. So the development of packings has been one of the big advances.
So, and what's the main impact of that? What do you feel we gain from it?
Well, there are one of the operating parameters is pressure drop on the contactor. And if the pressure drops too high, then obviously there's a knock-on effect to the economics of the process. So these new packings have much lower pressure drops. And so that impacts the fan size and the electricity usage for that. And then because of the materials they're made from, they have much higher surface area to contact the gas and the liquid. And so therefore you get higher rates of mass transfer from those packings.
What I find when I'm discussing with people for the first time CycloneCC and rotating packed beds is one of the most common questions I get is around mechanical reliability, because they see there's a rotating piece of equipment. So what would you say, what can you comment on about the reliability of this technology?
Well, you're right. People often confuse rotating packed beds with centrifuges, which operate at much higher rotational speeds. So the first point is really that rotating packed beds operate at hundreds of RPM rather than thousands, and so that's more typical of a pump. And if you think of them as being pumps, then that's a better ballpark in terms of their reliability. So then for pumps, it's all about the reliability of the seals, and basically those seals have been developed for pumps and can be transferred onto rotating packed beds. Of the rotating packed beds that are in operation, there are ones in the chemical sector which have seal lives of 5 years plus, and in the food industry 15 years plus. So I think the data is there that this is a reliable technology.
Absolutely. I think that hopefully helps bring some confidence to the customers as they look to implement this new technology, because nobody really wants lots of downtime, servicing. They want the same reliability that you can have with the equivalent technology, the kind of benchmark technology. So what do you see as the future and the kind of direction of innovation and R&D around rotating packed beds?
I think there are the things you can do to make the absorber smaller again. We now understand what happens to the liquid as it enters the rotating packed bed, and maybe by replicating that throughout the packed bed we can make them smaller. And then on the regenerator column, there's a big opportunity to integrate the regenerator with the heat transfer system of the carbon capture plant and thereby save energy. So I think developments in those two areas will take the technology forward.
Very good. And Paul, what sort of support do you see coming from government at the moment and other funding agencies to support innovation and development in this area?
Well, obviously I don't have any inside track on this, but I think that it's clear that carbon capture is going to be a big part of the mix of energy solutions that we're going to need in the future. And I think the government in the UK and around the world, I think, are hopefully going to get more and more behind it to make sure that technologies like CycloneCC actually get the right sort of market environment so that people will buy them and use them. I think it's one of the main ways that we're going to get out of the potential crisis that might occur on climate.
And Stuart, Doosan Babcock's history in researching carbon capture. You have a test facility in Renfrew, just outside Glasgow, where you've been doing a lot of research in the past. But that facility was mothballed for some time. What's it meant to the team at Doosan Babcock to now be working with Carbon Clean in testing and developing the CycloneCC technology?
Yeah, I mean, it's great for us to see that investment we made. We made that original investment in 2010. We did work to scale up that technology, and we obviously hit the carbon capture valley of death as such in the UK. So it's great to see that carbon capture is back on the radar, that the UK government and other countries across the world are investing within it. And it's been great to have Carbon Clean on board and doing that work at the facility. The technology is massively exciting. Next generation carbon capture, we see real benefits in driving down the cost and offering opportunities, and we're really excited to continue working with Carbon Clean to see that technology commercialised and on sites across the world. It's fantastic.
Thank you. Well, that just leaves me to thank the panel today for joining me for this fantastic and fascinating discussion. That's us from the studio. We're handing over to Cemex, where we're going to be finding out more about their scale-up activities that they're announcing today.
Thank you, James, for your introduction. It's my great pleasure to be speaking at this event and to be able to participate in this exciting launch. First of all, I want to say congratulations to the Carbon Clean team. At Cemex, we are very happy that we have found a strong and innovative partner on our decarbonization journey. We've heard much today about the development of CycloneCC so far, but I'm here to bring you the very latest news on its future. As you all know, CO2 reduction is one of the biggest challenges in the cement industry. According to the Global Cement Concrete Association, the cement industry is the source of 5 to 8% of the world's CO2 emissions. Although we have made significant improvements reducing our carbon footprint over the last decade, decarbonization and delivering net zero concrete within the next 25 years will require huge efforts from the industry, as 2/3 of our emissions are process related and very hard to abate. As one of the world's largest building solutions providers, we are committed to leading on the path to a low carbon economy. Therefore, Future in Action is our program focused on developing low carbon products, solutions, and processes to become a net zero CO2 company. Our ultimate goal is to deliver only net zero CO2 concrete by 2050. To achieve our goals, we are focusing our Future in Action program on 4 pillars. First, sustainable products and solutions like Virtua, an extensive family of sustainable products that includes the first net zero CO2 concrete, low carbon cements and concretes, as well as aggregates and mixtures available worldwide. Second, decarbonizing our operations by using alternative fuels, reducing the clinker factor in our cement, thermal efficiency of our cement kilns, or decarbonated raw materials. Third, promoting a green economy by collaborations within our industry and strong advocacy with key stakeholders as a crucial element for accelerating climate action globally. Fourth, innovation and partnerships. In order to achieve our 2050 goal, we need to discover and scale breakthrough technologies. Carbon capture and usage or storage will play a fundamental role to achieve our ambitious climate targets. Last year, CEMEX and Carbon Clean signed an MOU to work together for the purpose of demonstrating the potential of significantly reduced CO2 capture costs and establishing technology demonstration at one of CEMEX worldwide locations. Already in 2020, we carried out a feasibility study together with Carbon Clean to demonstrate a reduction in CO2 capture costs from our cement plant flue gas with an initial capacity of 100 tons per day. Today, I'm happy to share the news with you that we have appointed Carbon Clean to deliver a 100 tons per day CycloneCC feed study for our Rüdersdorf plant in Germany, which aims to be the first carbon neutral cement plant within CEMEX. The feed study encompasses the CycloneCC technology for a 100 tons per day CO2 capture plant, building up on the previously mentioned feasibility study. In parallel to that, we will perform a conceptual study for an additional 300 tons per day capacity scale-up, as well as a subsequent scale from 300 tons per day to up to 2,000 tons per day in the most cost-effective manner at Rüdersdorf, which equals approximately 50% of the overall emissions of the cement plant. At Rüdersdorf, we have created a Carbon Neutral Alliance as an umbrella for all of our decarbonization efforts for proven and innovative technologies, working together with different technology providers, startups, and research facilities. The CO2 capture unit will play a fundamental role in our CCU project Concrete Chemicals, which we are developing in Rüdersdorf under the umbrella of our Carbon Neutral Alliance initiative to produce synthetic hydrocarbons using hydrogen from renewable energies and the CO2 captured at the cement plant. In the first pilot stage, we want to capture 100 tons per day of CO2 and process it with hydrogen produced on site into synthetic hydrocarbons in the range of naphtha and kerosene. In a further scale up, we want to increase the CO2 capture by additional 300 tons per day in order to capture and use approximately 10% of today's CO2 emissions. The additional hydrogen for the project will then be supplied by a hydrogen pipeline. Both project stages have already been submitted for national and European funding and shall be operating by 2026. Please let me finish by quoting our CEO, Mr. Fernando González. Climate change is the biggest challenge facing humanity, and Future in Action must be at the core of everything we do. Not only because it creates value, but more importantly, because it is the right thing to do. Thank you all very much for your attention, and all my best wishes from Germany.
A big thank you to our audience today for being so engaged. If we don't get to your questions today, we will get back to you post today's event. So let's kick off with the first question. Pratik, I think this is one for you. What are the space savings brought by a CycloneCC system?
CycloneCC is modular, scalable, and easily installable system. Typically, conventionally, from 35 meter to 3 meter, it's a 10x magnitude size reduction CycloneCC can offer to industrial host site.
Okay, that's great.
Just to build up on that, Laura, I think it has huge potential to be able to reduce the cost and size by up to 5 to 7 times, sometimes 10 times as well. Depends upon which industrial setting you are in, but certainly is a game changer in terms of saving the space.
Okay, great. And the term coined by Pratik was modular. What do you mean by modular?
Well, modular is basically anything or any equipment which is prefabricated, skid mounted, designed somewhere else, and it gets to your site. Just get dropped there and you connect it and you get started. It's exactly as the modular. What it does is it allows you to scale up the technology, scale up the installation on site sequentially as you grow. And at the same point of time, it allows you the benefit of cost reduction because it's all modular, it's all prefabricated, it's been designed many times. It just gives you a lot of cost benefit as well.
Okay, great. So back to you, Pratik. How large is the capacity that a single CycloneCC module can reach?
I think initial engineering estimate to give us an idea about 500 tons per day. So far, we have done successful engineering design for 10 and 100 ton per day CycloneCC already with CycloneCC.
Laura, I'll probably just build up on that because it's a very important point of the size. Depending upon which industry you're in, the size ranges could vary, and hence modularity comes again there. If you have 500 tons per day as one box, and you can replicate it as many times as you want, just keep stacking them, and you have 1,000, 2,000, 3,000 ton per day CO2 capture plant.
Okay, great. Starting to make sense. So business models question now, timely. I'll hand this one across to you, Ian. Tell me more about the carbon capture as a service business model that Carbon Clean are introducing.
Yeah. So that's a really important question, Laura, because it plays very much into what we know our customers want, but it's also central to our strategy as an organization because we want to offer customer excellence and we want things to be as easy as possible for our customers. What our customers want is, first of all, ideally not to have to finance these plants up front. Secondly, they want predictability of what that cost of capturing each ton is going to be. Thirdly, they really want to pay on results, so they only want to pay for what is captured. And if you think about where we're targeting, which is the smaller dispersed sites, they're not going to want to have engineers and experts employed at these sites to look after another element of the plant. They really want this aspect of their operations dealt with by the specialists, which is us. So everything we're doing, and CycloneCC in particular, is geared towards achieving all of those benefits to deliver CAS. Now, on top of that, to be able to deliver CAS effectively and economically, you've got to have predictability on the supply side. You've got to have predictability of the cost that you incur, how quick it is to deliver and install, so that that's stable at each plant, each instance. Only then can you build a viable model and then partner with infrastructure funds and other financiers to put together a package for the customer.
Okay, great. We've clearly got an advocate in the audience, and it brings us on actually nicely from that business model. If demand is driven to the levels that you foresee, how are you going to ramp up the production to meet this demand?
So I'd say it's when, not if, because we're very confident of the demand levels growing for this solution. And we're very excited about the supply and manufacturing side. So we're already looking at a range of options, and that will include working with some of the world's largest engineering companies to deliver those solutions. But ultimately, our goal is to build what we term a mega factory. We want to actually build our own presence that we research, we develop, we employ and skill up people. We actually start to build these in a production line, because at the moment, the solutions for carbon capture are very bespoke. They're designed individually, they take 18 months to install. We really want these rolling off of skids on production lines, put into containers, shipped around the world and installed within 6 months in a standard way. So having a factory, having facilities and capability to do that is central again to our strategy.
And I'll probably build up on that, Laura. I think it's very pertinent to the overall decarbonization and net zero strategy that everyone wants to achieve now, all of our customers want to achieve. If you look at the global installation capacity to capture carbon dioxide, that today hovers around 1 to 1.5 million tons. This is all the companies around the globe working together. It will not be enough to achieve 1.5 degree scenario, which IEA says will be required by 2030 or 2050. To be able to achieve that, you need a Tesla type model where these units are skid mounted, they're modular, and they're mass produced so that they can be deployed very, very quickly out there onto the industrial sites. Sometimes, maybe in less than 8 weeks as well.
Okay, great. So we're still on cost actually, and Prateek, back to you. So how does OpEx of CycloneCC compare to conventional technology?
I think the OpEx of CycloneCC is much lower than conventional carbon capture system because the kind of innovation we have built in CycloneCC with respect to intensified solvent, less water solvent, as compared to conventional because of rotating system mechanism in CycloneCC, along with you don't need high balance of plant, high piping running here and there to really cut short the energy loss. So all in all together, if you combine lead solvent makeup, less energy input, so all in all the CycloneCC OpEx cost is significantly less as compared to conventional carbon capture system.
Can you put a number on that?
What was the number? Combining CapEx and OpEx together, it is 50% less as compared to conventional carbon capture.
Okay, great. So what actually happens to the CO2 that's captured? I think one for you, Anirudh.
So that's the whole crux of the solution, right? I mean, you can basically do two things with the carbon dioxide once you've captured. You can either utilize the carbon dioxide on site to produce a product, which is what we do at our site in India, where CO2 is captured, it's converted into a chemical, which then goes into detergent manufacturing factory of Unilever. And hence there's a very nice circular economic example. The second option is to store the CO2 safely and permanently underground, thereby achieving large-scale storage of CO2. I think, to be honest, both the options are required as we sort of go forward. I'm really excited about options to be able to produce carbon-neutral fuels. For example, a project we have in Sweden, Liquid Wind, where CO2 will be captured, mixed with hydrogen produced from offshore wind to produce carbon-neutral shipping fuel. I mean, really think about it. Decarbonizing two industries. It's not just an emission, but also decarbonizing shipping. But then as we sort of move forward, I think we would need that mass storage capacity to be able to decarbonize a whole load of heavy industry out there.
I'd add to that as well that referring back to the capture as a service, this is a natural extension of that. Compression, transportation, and then utilization or storage is something our customers ask for and will require on top of the capture as a service. So we are working to see how those could be put together with worldwide partners so that we work in partnership and offer a combined package to our customers.
Okay.
I think I would like to add one point here. I think you mentioned about utilization. A lot of utilization options are not economical because cost of CO2 as of today. With CycloneCC low cost target $30 per ton, most of the utilization options can become feasible, which are not feasible as of yet, and that it can really just disrupt the market significantly in terms of more and more utilization option for completing the whole value chain.
Okay, great. The solvent's been mentioned a couple of times, and I've got a solvent question that's come in. Does CycloneCC use the same solvent as your conventional solutions?
It has same family APBS, but it is tailored very specific to rotating system, which has uniquely engineered to support kinetics and the mass transfer together to really tailored very specific to CycloneCC application.
Okay, great.
I think point to noted that CycloneCC for carbon clean CycloneCC is globally protected in more than 21 countries, patent granted, and it's really high time to really scale and really put forward that innovation into the market.
Okay, great. I think closing question, will CycloneCC completely replace all conventional carbon capture technologies, or are there applications where it is suboptimal, and if so, what are these?
Very good question, a very broad one. I would just say that, look, there is no silver bullet as far as decarbonization is concerned. CycloneCC is specifically geared towards heavy industry, which is steel, cement, waste incineration, refining, and chemicals, where space is very limited and cost has a very big impact on the bottom line or the margin. So there's a place for CycloneCC, and we believe that we can work very, very closely with these sites to decarbonize them. However, conventional carbon capture technology will be required for decarbonizing, for example, large power plants. We're talking about gas-fired power plants, we're talking about coal-fired power plants in some regions as well. So I think it'll be a mix of solution. However, CycloneCC, we believe, will have a special place, specifically within the heavy industrial decarbonization scenario.
Okay, great. That was the final question. There are many questions that we didn't manage to get to today, so we do promise to engage with you post today's event. And we're going to hand across to Ian now for the close.
Wow, what an exciting day for both Carbon Clean and the journey towards net zero. I am Ian Tobin, Chief Corporate Officer of Carbon Clean, and I'm delighted to bring this event to a close today. The first panel talked earlier about being on the cusp of a new era for carbon capture, but I actually believe it is the new era, with Carbon Clean's CycloneCC solution as a catalyst for wide-scale industrial adoption of CCUS. So what is the scale of the opportunity? There is huge potential global demand. The IEA believe that carbon capture, utilization and storage will become a $1 trillion market, and their data shows that CCUS is an essential tool in addressing climate change. There needs to be a 500-fold ramp up in global equipment capacity from today's installed base. Reiterating Anna Ruud's earlier remarks, a big thank you to our team, customers and partners that have made this innovative journey possible, but also to our investors and shareholders that have backed us each step of the way. This event has been both fascinating and inspiring, but it's not just about the past 2 hours. We're looking ahead at the next decade of delivery. As Laura set out in the introduction to the event, we're absolutely committed to taking the urgent steps needed to ensure that CCUS is available to contribute to net zero goals. So what's next? There are 2 key fundamentals that I would like to highlight. Firstly, the rollout of innovative business models. The market has shared with us that they want to see a fully funded model, and that's where our Carbon Capture as a Service, or CaaS, business model comes in. It provides customers with a streamlined and simple means of capturing carbon, with payment for tons of carbon captured, with all aspects of the service delivered by Carbon Clean. Through strategic partnerships across the supply chain, combined with our modular technology, customers can finance CCUS projects over a longer period, start their decarbonisation journeys today, and progressively scale up to achieve their emission reduction targets over time. Secondly, strategic investment. The key to cost reduction per tonne of carbon dioxide captured is the development and manufacture of efficient standard specification plants with a smaller footprint, which are capable of being quickly delivered and easily installed. Carbon Clean's CycloneCC technology is designed to deliver these benefits across the globe. Achieving this requires significant upfront investment in high technology manufacturing facilities, leveraging domestic skills and knowledge, and nurturing strong domestic supply chains. This investment is iterative as the technology will continue to be refined, delivering many more benefits such as increased cost reduction and reduced energy consumption. In addition, the ability to embed these developments quickly into production units requires parallel investment into closely integrated research and development facilities.
With COP26 getting underway on Sunday, CycloneCC will hopefully focus the conversation around industrial decarbonisation. This next generation technology is driving down the cost of carbon capture to the point where all essential heavy industries, such as cement and steel, can play their part in mitigating climate change. I'm going to leave you with a short final view of CycloneCC, and if you're up in Glasgow for COP26 or want to register your interest in a site visit at another time, let us know. Seeing is believing, and size really does matter.